All right, so operator overloading. So what is operator overloading? So before we get there, let's review. It's been a while, right? We had a break, a long break, 2 weeks actually, because we happened to not have class on last Thursday. So let's review, I would say, all the classes. So we spent 3 weeks on classes, and it's quite long, and a lot of concepts and new things for C++ happen in classes. So let's do a short review, and we build on top of that, which is the operator overloading. Okay. So at the very beginning of the first lecture of the classes, we went into basic content of what's included in a class. We have class members. Class members will include variables of a class, right? Attributes or things that you can set. Functions of a class that are representing action that you can take for an object. And we'll also went into a little bit more detail of mutators and assessors, so setter and getters, why we have them, how they're used, right? Then we went into how we write classes in C++, how we split them into interface and implementation. Interface can be left in header file ended with .h or .hpp. Implementation is a file ended in .cpp, right? So we look into a little bit more detail of what you need to write in header file, specifically the if and if protector, right, in the header file. And finally, we talked about access specifier. It's how you restrict access for each class. It can be completely public, everyone can have access to it. It can be completely private, where only the class itself has access to it. And we also mentioned that there is this protected, but we haven't talked about back then, right? So that was kind of the at the beginning. And then we went into constructor and destructor, where in the constructor, we talked about where you can set default variables or default parameters so that you can have initial values set for the class attributes. We then talk about destructor is what is used to destroy the object when you're done, right? Either you finish the whole program or you jump out of the scope. We then went into friends. We have example for friend function of a class and friend class of a class, where we show you a friendship can only be declared one way within the class that wants to open up to, say, function or other classes, right? And finally, we talked about some of the new, like semi-new content, right? Constant, you already know constant as variable constant, but we talked about constant function and how that is used and how that is different than constant variables and how constant function works in classes. Static, again, we talked about how static is used in classes. And then finally, we talked about the this pointer along with templates, where the this pointer is where you use to access the object scope, right? Static is where you use to access the class scope. And template is very similar to the template with functions, but we didn't cover classes when we talked about template. So we then gave example of template with classes after we finish all the content of classes. Right? Question? All right. With that short review of all the things we covered in classes, let's go into this new content called operator overloading. We actually touched on this a little bit. We didn't tell you how to write or how to do the operator overloading, but we did show you that how you can use some already overloaded operator. So let's look at that to start with. Operator overloading is itself a process to allow C++ operators to work with different objects, meaning that the operator with the operand can be different types, right? So that's what the overloading of operator can be used for. For example, things that you are very familiar with by now is the string. Remember, we have very early on in this class started with string and how you could use string instead of char array to operate on letters and text. So string, when we first introduced it, we said that there are a couple operators that you could use for string to manipulate multiple different strings, right? So one of it is this addition operator, this plus sign. When we have two strings plus with the plus operator in between, it acts as appending, right? Appending two strings together. Now remember, before we talked about string, when you just use plus operator for integer, float, or any other numerical classes, it's addition. It's simple addition, right? You are adding the number together, give you a sum. Where when you are using the same operator, the plus, but for strings, so that's different class, it acts as append. So this behavior of changing how an operator works with different classes is basically called overloading. So what happened in strings is that it's overloading this plus operator to have specific behavior for strings only. So when you have plus sign for numbers, integer, floats, double, and so on, that's addition. But in the class of string, it overloaded that operator to have it work as append. So that is called operator overloading. It's overload how an operator being used for a specific class. So one rule of thumb is that C++ actually does not allow us to create new operators, only to overload existing operator. So if there's plus sign, minus, greater than, smaller than, greater than, equal to, and so on, those operators already exist in C++, and it's being used very commonly for other classes or fundamental types, right? Integer, float, double, and so on. Those operators, when you want to use those for your class, you can overload the way to use it specifically tailored to your class. But you cannot create new operators in C++. Okay? And that's kind of explanation of the concept. But let's go a little bit into detail of strings and kind of remember how strings very different than other numbers, numerical types. Question, yeah.
Wait, I have a question. So I tested the code and wait, class string is a type of class? Class string is a type of class?
String type is a type of is class, yes. So type and class in C++ are no difference. Remember at the very beginning, we said C++ does not distinguish fundamental versus user-defined. So everything like integer, float, string, student, account, all the things that we have shown as example, C++ treat them completely equal. They're all the same. They're all types or they're all classes.
Wait, so line 7, 8, and 14, they're all classes?
Yeah, classes and types are the same in C++. So integer versus on C++ perspective is same as string. S1 and I1 are just different objects of different types. S1 is of type string, I1 is of type integer. That's all. So you can think of types are the same as classes. And when we say class string, what we're saying is this type is defined by class string.
Okay.
Yeah. All right. So here's an example of how we've been using or how the operators are different comparing to integer and string. A very short example where we created 4 objects at top. We have 2 strings. One is S1 and one is S2. We have 2 integers, I1 and I2. They all have their initial value. String 1 is apple with a space, and string 2 is pen. I1 is 25 and I2 is 50. So let's look at first operator, plus. When we have I1 plus I2, that will give you a sum, right? But when you have S1 plus S2, that will give you an append. So we'll see. So we'll see apple pen for a sum, and we will see 75 for I sum. Yeah? Less than. Less than operator is also overloaded for string. When we are using less than to compare 2 integers, you're comparing which number is larger, right? So if I2 is indeed larger than I1, this will return true, otherwise it will return false. When you're looking at string, what is using this less than to do is to compare the alphabetic order of 2 texts or 2 strings, right? So compare A with P, P with B, P with N, and so on. So that's how they're different. Equal, equal to. When we are having 2 equals, so this is an operator, right? Equal, equal, that's an operator. When we're using this operator for integers, 25 and 50 are not equal, this will return false. So I equal will be false. And here when we are comparing S1 and S2, it's again checking one letter at a time. So here A and P are not equal, and this will return false. So you see that each of the operators are slightly different. However, you can still see that this is adding 2 things, either int numbers or string. This is comparing 2 objects, either integer or string. Again, this is comparing 2 of them, right? So the meaning of the operator are slightly different, but they should still be the same, right? I'm not having the plus operator of 2 string to give me the difference between 2 strings. I'll have them append because that's just another form of adding, right? So adding 2 strings together will be understood as append. Yeah, question.
So wait for line 18. So we're comparing the string number 1 is less than string number 2. So does it count the number of letters or the capital letters or the?
It also does count a number. So it will look at which string is longer, right? So like if this one is longer than that, then S1 is greater than S2. It will also compare the letters. So if A is greater than P, then that will, if A is less than P, then that will return true. So it's doing string comparison instead of numerical comparison.
Wait,
Similar to here, right? It will make sure the 2 strings need to be equal length and equal letters. They have to be the same length. Also, all the letters within S1 and S2 are completely equal. That's when the 2 strings are equal.
Wait, what if the two strings is the apple and instead of pen, it's also apple but in all caps?
That's not equal. When they compare smaller letter A and capital letter A, that's not considered equal.
Also, it,
Don't have to be exactly the same.
okay, so it uses the ASCII value.
Yeah, basically. Yep.
Okay, all right.
So this is an example of how strings been overloading operators, right? So the plus operator, the less than, and then the equal equals to are all overloaded by giving it a slightly different meaning or slightly different behavior comparing to the default, right? When it's used on numerical values. So the behavior of changing an existing operator to be better fit to our class, this kind of behavior is called operator overloading. All right, so now I understand what it's used for. Let's see how we can do it, right? Understand what it's used for. Let's see how we can do it, right? How to overload operators. So say that we have say that we are writing the class string, right? The way we overload an operator is still by defining a function. However, the function has a very specific naming convention. When you have an operator overloading function, you write a function and the name will start with spelling out operator with the actual symbol of the operator followed by it. And that will be your function name. So whatever operator you're overloading, you always need to start spelling out this operator with the symbol after it. And that whole thing is your function name. So that is the function name. And whenever you have that function name, then C++ would know that this function is what you're using to overwrite or to overload a specific operator. Okay. So you see that there's more things than the function name. There's return type, there's parameter, and there's const. We're going to go into detail of why we have them and what they're for. Right. So before we do that, some rules for operator overloading. Operator overloading is not automatically generated. You must write operator overloading function for each of the operator you want to overload. Okay, very specific. You have to write them. There are two ways that you can overload an operator. So we talk about we want to use functions, but there's different type of functions that you could use to overload. You can use non-static class member function, or you can use regular function, or we call them non-member function. So remember what member functions are? Member functions are functions that belongs to a class. Regular functions are functions that do not belong to a class, right? And remember static? Static is a class scope function. Non-static is an object scope function. So non-static member function is one way you can use to overload. A non-member function or regular function is another way you can overload. So we'll show you examples for both and how we use them. Okay. Another thing to point out before we go into the detail of the implementation, there are 4 operators that are not allowed to be overloaded in C++. That includes member operator, so the dot. Remember account.username, account.password, something dot something. So that is the member operator to use to access the member username of object account. So that operator you cannot overload. Pointer to member. So it's the dot star operator here, dot star operator. That also cannot be overloaded. This is accessing a pointer of a member, right? The pointer to password of them account or pointer to username of account and so on. So that you cannot overload. Scope operator, the column that you've been seeing, you cannot overload that either. Okay, so cannot overload scope operator. And finally, the conditional operator, which we have not been seeing quite often. This is a one-line if condition. The operator is question mark with the column, and the way that you use it is condition, question mark, if condition is true, column, if condition is false. We have not used this as much, and this is not a recommended way to write if. We have been asking you to spell out the if condition and then the different results of the condition. So don't need to worry too much about this. Just to remember that you cannot overload this operator, and this is conditional operator that you cannot overload. Yeah, question.
We have a question. So line number 7. So the return type would be a Boolean.
That's right.
Then and the name of our function would be operator.
Operator less than. You have to have this.
It's not like a type of name. Is there like an operator?
Type of name. Yes.
So there's like operator plus operator equals.
Exactly. Yes.
Okay, and inside the parentheses would be the parameters. So return type of const and string.
Oh yeah, I mean this yes. So we'll talk about what this is, right? Why do we have that? And then const is the type of the function. It's a constant function for performance. We're also going to.
Wait, is that like new? Because isn't it JavaScript?
Wait, what was new?
A const isn't it JavaScript?
No, we talked about const. I think the last class is 3. I think where we talk about constant function. Remember, where a constant function in a class that's different than a constant variable where you cannot change.
Okay.
Yeah. So that's constant member function of a class. All right. Summary of some of the rules that we mentioned, and also something we're going to cover. So first thing we talked about, we cannot create new operators, right? Rule number 1. Number 2, operator overloading. We don't want to change how the fundamental type works. For example, plus, right? If it's a plus, that means something is adding together. No matter it's strings or numbers or students, it wants to mimic the behavior of adding. We don't want to overload the plus operator and have the behavior of subtracting. Okay. This is not something that's enforced by compiler because there's no way compiler knows. However, it's more of a rule of thumb for us as software engineer. When you overload an operator, make sure that you still apply with what that operator was initially intended to do. If it's plus, then even though when you're overloading, make sure you're still doing something for adding. If it's subtract, then do something that's similar to subtracting. If it's greater than, if it's smaller than, make sure you're doing something that's comparing. So at least, still try to kind of follow what that operator was initially intended to use for, but you can change the behavior a little bit to fit better for your class. Third, the return type are limited by the expression in which the operator is expected to be used. So this is very similar to number 2, is that we don't want to change too much about the operator when we overload them. That includes how it was initially intended to be used, and also how the types are intended to be returned. If it's greater than, smaller than, equal to, those are supposed to be comparison, and the return type of those should be Boolean, right? False or true. Plus, minus, plus equal to, and things like that, those are supposed to be adding two things together and return an object, right? Not a Boolean. So then we also want to follow that. We don't want to change too much about the default behavior. All right, the next one, related operator need to be overloaded separately. So we also mentioned this a little bit earlier, where each operator needs to have its own overloaded function. Okay, things that's related, for example, the plus versus the plus equal to, you will say, well, they're the same, right? They're adding something together. Even though they're somewhat related, you still need to overload them separately. So that you need to have a function called operator plus, you need to have a function called operator plus equal. Okay, so you need to overload them separately. The number of operands an operator takes cannot be changed. This is also something similar to number 2 and 3, where we don't want to change too much about how the operator was initially designed. There are three types of, three different numbers of operands that you can use for operator. There are operators that work with only one operand. We call it unary operator. For example, the plus plus, right? When you use the plus plus operator, you always have I plus plus. You don't have I plus plus J, right? So you don't have one operand in there, and either go at front or go at behind, go behind the operator, but you only have one. Binary operators are the plus or the equal to or the greater than, the smaller than, and things like that. Those always have two objects, right? Either you're adding two things together, you're comparing two things, you're appending two things. You always have two operands for that operator. So those are called binary operators. And finally, there's only one ternary operator, which is the conditional. And that cannot be overloaded. So we basically do not need to consider that at all. So at the end, we will only be dealing with two types. The operator that only work with one operand, the unary, and then the operators that work with two operands, the binary. All right. Finally, operators such as ampersand, star, plus and minus that can work on both unary and binary versions need to be separately overloaded. So there are operands that can work with both one operator that can work with both one operand, act as unary operator, can also act as binary operators. For things like that, you need to separately overload them. Okay, so that kind of is following this rule where every single operand has intended to be used has to be overloaded separately. Okay. All right. Question.
Wait, I'm not sure. What do you mean for the first bullet point? Can't create new operators. Like what does it mean?
So C++ have a set of operator that was already created, right? The plus, the minus, and all those are operator that's already created.
Yep.
There are operators or there are symbols that are not used as operator. So if you look at your keyboard, you have $sign. That's a symbol, but that's not an operator. That's just a string, right? That's just a symbol.
Right.
That doesn't mean anything. So you cannot be like, I'm gonna assign some meaning to the $sign to use it as operator. You cannot do that. So you cannot create new operator.
So I can't use like $1 $1.
So you cannot, because that will be creating an operator.
Yeah.
Yeah, so that's what that first means. You cannot create new operator.
Okay.
So the one that's already act as an operator, right? Like the plus, the minus, the star, ampersand, explanation mark. Those are already those are already operators. Then you can overload them. You cannot create new ones.
What does like overload like mean? So
It
like,
means overwrite a little bit, right? So when you remember before we talked about function overloading or function overriding, where you have the same name of a function, but you give it a different meaning.
okay.
This is the same thing, but for operator. It's the same operator, but give it a slightly different meaning or actions, right? How does operator work?
Oh, so from like the last slide on line number 7, we can put the operator less than twice.
That's actually the insertion operator, right? The CL, the CN, you mean that? If you have less than twice, that's an operator that already exists. So yes, you can overload that.
Oh, okay.
Yeah. All right. So before we go into examples, we want to also introduce this new way of passing parameters. Remember, we had 3 ways of passing parameter before. We have pass by value, pass by reference, and pass by pointer, right? So let's review what's pass by value. Pass by value is where the compiler will create a copy of the parameter for you to operate on inside the function, and you can change it however you want. However, because it's a copy, when you're done with it, it's done. The original parameter will not be modified. Pass by reference and pass by pointers are similar in the way that there's no copy being created. The original parameter is getting directly passed in as a parameter, and you can, when you change it, you change the original variables. Right? So we're looking at those two category of ways. We talked about pass by value. It's really safe because you're creating a copy, and when you change that copy, nothing in the original variable will be modified. So you can be very safely assume that, okay, my parameter will not be modified by whatever function when I pass in by value. However, that could be really expensive. Imagine that you're passing in a very big object, and every time you pass it in, compiler will create a copy of that object. Then you could create multiple copies, so that could potentially be costly. Now, pass by reference or pass by pointer will not have that concern. It will not be expensive because there are no copies being created. However, it may not be as safe because you are allowing whatever function that you're passing in to directly modify the original variables that you're passing in. Now, can we get the benefit of both by having another way of passing parameters? So that's what we're covering today. It's pass by constant reference. So we talked about constant, where it's constant that you cannot change it, right? It's non-modifiable. Now we also talked about reference, where you pass it in by the original value without creating a copy. When you have constant reference, what we're saying is that we are not creating copy. We are passing the original variable as it is, but we cast it into constant, meaning that you cannot modify it. Okay? So when you pass parameter by constant reference, it's not costly because we're not creating a copy, and it's safe because we cast it to constant, so it will not be able to be modified. Okay, so now this class, we're going to start to use this constant reference. All right. Let's go back to, so with that, let's start with some examples. So we'll start looking at binary operators first. So with some examples. Let's go back to, so with that, let's start with some examples. So we'll start looking at binary operators first. So what's binary operator again? It's an operator that only have one operand, right? Oh, sorry. Binary operator is the one that with 2 operands, right? It's binary. For example, the plus, the subtract, equal to, the greater than, the smaller than that we have shown before are all binary operators, and they're really common, right? Where one operator sits in between and 2 operand, one on the left and one on the right. So any operators in that format is called binary operators because it has two operands to operate.
I have a question.
Yeah.
Wait, so it's like so is the increment symbol and the decrement considered a binary? The plus and the minus equal sign?
The increment, you mean the plus plus, right?
Like for for a for loop, at the end we usually put
the plus plus, I plus plus.
Yeah.
Yes, that is unary because you do I plus plus. So plus plus itself is an operator, and you only have one operand, right? Either I plus plus or J plus plus. That is one single operand, so that is not binary. Binary is where you have I plus J. You have two. You have S1 plus S2, S1 greater than S2. So you always have two things, one on the left, one on the right. That's binary.
Okay, and the non-static member function. So a member function would be like all the variables inside the function, but what does non-static mean?
Member function means function of a class, right?
Function, okay.
So the function that you define inside a class are member functions. The function that you define outside of a class are regular functions because they do not belong to, they're not members of anything. They're not member of a class. So those are not member functions.
Okay.
So remember in the class you have static versus non-static, right? Static is class scope, non-static is object scope. So make sure that you do not use static function to overload. Use regular member function to overload.
Okay.
All right, so we're going to show you both, right? So we have binary operators that we're going to show examples of. For each of the binary operator, we're going to show you two ways of overloading. The non-static member function and the non-member function, which is regular function. Here's a summary of the two first. Non-static member function, when you use that to overload binary operator, will take in one parameter when the left operand is an object of the class. The non-member function will take in two parameters where one of the parameter must be either a class object or a reference to a class object. That's kind of a summary, that's a lot, but once we get into the example, you will see what I mean, right? And then you will see why we do it that way. Here, a non-member operator function often is declared as friend of a class so that the function can access members of the class. Remember when we talked about friendship? For a class, for a function to access a class object, it needs to be a friend or it's completely public. So a lot of the time your class are not completely public. You have some sort of private things in there that you're protecting. You don't want it to be public. So for the compiler, for your overloading function to access all the members, then you want to make sure that you declare friendship. Okay. All right, so there's a lot of contents. Let's go into examples so you know what I'm talking about. So let's start with this binary operator greater than. Okay, so we're gonna start with greater than. We're gonna start with member function overloading. So member function. Okay. I'm gonna have a class student. So we're using our same old student class example. In here, the student has name, 3 test scores, and an average, right? So the same student class example that we've been using. On the top, and here they're all private. On the top here, I have my overloading function. Remember, operator overloading function has the name operator followed by the symbol. So since we're looking at this greater than operator, so the function name will be operator greater than. So that's my function. Okay. Now, the return type of a greater than operator will always be Boolean, right? When you compare two things, they could either return true or false. So keep that, we're gonna have Boolean. All right, let's look at here our parameters. So here parameter, we first of all have a constant reference. So we talk about this new type of passing in parameter. Constant reference is where you want it to not be costly, meaning that we're not going to create a copy, but also safe. So constant reference. And what we're passing in is our class student, and this is a constant function. So why do we have that? Let's go to the left. Let's explain when we are comparing two object here to students. How does the compiler look at this part? So when we are using the greater than operator, what you write in code is A greater than B, or S0 greater than S1, right? Or 5 greater than B, right? Things like that. When you write something greater than another thing, the compiler will immediately translate that into something like this. It will translate this into a function call. And the function call is called from the left-hand side operand, which is S0. So S0 dot operator greater than, that's the function name. And then right-hand side, which is the S1, will be the parameter. This is how compiler will read your code. So your code is top here, right? You write A greater than B, S0 greater than S1 in your code, in your C++ code. When you compile it, when you actually run it, compiler will read this and translate that into this. Okay, so the left operand dot function call to the operator, right? So operator greater than, and then right-hand side as parameter. Okay? Because of that, for us to overload that, we have to follow this rule. Okay? When we follow this rule, we are essentially having a function operator greater than that takes in one parameter that is the right-hand side as well. Does that make sense for this part? When you write this in the program, compiler will read this. And because compiler read it as this, when we overload it, we need to make sure they match. So that when the compiler are running this, it will then go to my operator overloading and run this instead. So that's why we have operator greater than as a function name, and we have an object as the parameter, and the type of the parameter will match the right-hand side, the right operand. Question?
We have a question. I don't know how did we get the S0 is greater than S1? Where did that come from?
Oh, the top, this part?
Yeah.
That is what you write in code, right? So say we come here, this is my main. And when you're comparing students, what you write is S0 greater than S1. You don't write S0 dot operator greater than. You don't write that. When you use an operator, you just do A greater than B, right? A plus B. When you use it. Similar to if we go back here. Here. This is how you will write in your main, right? You either do plus in between and two objects. You do less than in between two objects, equals to in between two objects. That's how you would write code, what you would type in your C++ file. Compiler doesn't read it like that. When compiler read that, it will translate it into a language that it will understand. And here I'm showing you how it will be translated into. Yeah.
Wait, so we're what for the line 7 student and symbol, is that like reference? Are we
Yes, constant reference in here.
Oh, okay. So does that mean that it will whatever code happens inside the function will change the original value and also create a copy?
No, so it will change the original value. Yes. However, we cast it into constant, so it's not allowed to. Remember reference, like you said, right? Reference allow whatever inside the function change the original variable. Yes. However, we added a constant at front, meaning that I cast this reference into a constant, you cannot change it anymore.
Okay.
So it will pass in the original, yes, it will pass in the original student inside the function, but as a constant, meaning that no one can modify it, like protected in a way. All right. Okay, so that's why we have the definition on the right. It's because how your compiler translate the operator, right? Here I put a note, constant reference. Constant reference is used when we do not want to copy, right? Because it's reference, but we also don't want people to modify it, the function to modify it. So we pass it by reference, so that won't create a copy, but we cast it to constant, so people cannot change it. So that's a constant reference, and that's what that is. Okay. One last thing, you note that at the very end, I have this as a constant function as well. So why do we have that? Greater than operator is comparing. Remember when we talk about constant, we say that whenever a function is not modifying anything, we want it to be constant. So our greater than operator won't modify anything. It will not modify student 1, it will not modify student S0, we will not modify anything. It's just comparing and return true or false. Therefore, it can be a constant function. Okay. All right. So now let's look at how it's used, right? Down here, it's going to be my main. In my main, I will have student S0, student S1, same student. We actually asked the one we created for our previous example. So May, 89, are the test score. Zen, 95, 86, 92 are test scores. Now, here I want to use this greater than operator to compare two students. Okay. If I want to compare May and Zen with the greater than operator, I will print out May greater than Zen is true or false. Okay. Line 55 is another formatter. Remember the fixed that we used in project 1. Remember the flotation point that we used. And then bool alpha is where I'm formatting a Boolean type into a string. So Boolean is true or false, but that is 0 and 1 in compiler. So if I simply print S0 greater than S1, it will give me number 0 or give me number 1. Okay. But what I want is that I want you to tell me whether it's true or false. And the way I ask cout to print out true and false instead of 1 and 0 is to say format Boolean as alphabetical, meaning as strings, as letters. So down here, you will see the print very pretty and be May greater than Zen is false. If I don't have that, this will just be 0 and 1. That's just a format. Okay, it's a formatting Boolean. That's it. All right, so going back to the greater than. So here, we want this S0 greater than S1 to return to me true or false, to tell me whether May is greater than Zen, right? S0 is May, S1 is same. Yeah. Now, when we write this, and when the compiler got to line 56, you will need to evaluate this part. When I evaluate S0 greater than S1, it will first translate it into S0 dot operator greater S1. Okay. Now, S0 dot operator greater S1 is a function call of a member function S0. Right? A function named operator greater than of class student, right? S0 student, that takes in a parameter student, which match perfectly with our definition over here. So function name operator greater than of class student takes in another class student. Returns a Boolean telling us true or false. Okay. So this is an example of overloading greater than with member function of a class, right? So this function is a member function of class student. So using member function and non-static as well, right? This is no static, so we didn't say static. So non-static member function of a class to overload operator greater than. Okay. All right. Next up, we have non-member function. So now I have greater than, let's overload greater than equal to. But this time, we want to use non-member function. So if you look at greater than equal to, it has no difference than greater than, right? It's same thing where you have a left operand greater than equal to right operand. So S0 greater than equal to S1, right? Now, remember the member function overloading, we said that the compiler will translate it for you. If you have non-member function overloading, the compiler will also translate it for you. The compiler will translate it into a non-member function that takes in two parameters. The first one is the left-hand side, and then the second one is the right operand. See how they are different? If we go back here, when we have member function overloading, compiler will translate S0 greater than S1 into S0 dot operator greater than S1. So a member function of S0 that takes in one parameter versus non-member function overloading, it will translate this into a regular function call that takes in both the left-hand side and the right-hand side. So it will take in two parameters. Okay. And also this is a regular function. So you do not see the S0 dot anymore. So it's not a member of anything. It's just a function. And the function name is operator greater equal to. And takes in two parameters, S0 and S1. Okay. Now, with that, let's look at here. Because we have a regular function that's going to take in S0 and S1 and operate on it, right? We're going to compare the two. We're going to compare their attributes and things. For this function to access anything of my class student, which are all private, it needs to be a fit of the class. So that's why initially at the very beginning, I said non-member function overloading most of the time needs to be a friend of the class for it to actually work. So this is why, right? When you have an operand that's going to take in S0 and S1, for you to compare them, you need to access their test score, maybe their average, or maybe their name, however you want to compare them. and all of them are private, meaning that this function initially does not have access to any of them. So that will not allow you to compare anything, right? So for example, here, this function, I wanted to compare the names as strings, but I don't have access to them unless I have the friendship declared inside the class student. So class student will have friend, Boolean, operator greater than equal to, takes in both parameters inside class student. So this is a friendship. Down here, line 18 to 20 is a regular function definition. Boolean is return type. Operator greater than equal to is the function name. Two parameters, S0 and S1, both constant reference to make it safe and not costly. Inside the function, you can do whatever you want. You can either compare test1 over test2. You can compare average 1 over average 2. You can compare name 1 over name 2. So you can then define how you would like to use the operator greater equal to. Okay. Now let's look at this. The way we use two operators are exactly the same. So when you write in your main, you don't really care whether it's overloaded by member function or overloaded by non-member function. It's all handled underneath by the compiler. So you don't need to worry too much about that. And all you need to care about is how you will want to choose to overload them. At this point that we talk about the binary operand, they're optional. So you can either choose to use member function, or you can choose to use non-member function. They're equivalent. You can do whichever you want. Okay. However, there are some times where you cannot. So let's look at, let's see how many more. I think I have 2 more examples. Yeah, let's look at this, another example. Again, binary operator, but plus equal to. Remember what the plus equal to means? It's equivalent. So when you say test1 plus equal to 5, it's equivalent to test1 equal to test1 plus 5. So you add 5 to test1 and assign back to it. Test1 plus equal to 5 will modify the left-hand side to test1, right? So this is an assignment operator because it's modifying one of the operands. When you are overloading assignment operator, we want to make sure that you return the left-hand side, which is modified, by reference. And we want to use that, do that by start this. Remember that this pointer and then the cascaded function call and things from, I believe, classes 3. So we're using that here. The reason that we are having assignment operators to return by reference is to allow cascaded function call. Right? So that link back to our classes 3, where we say the reason we want to return star this is to allow cascaded function call. So that match here. When we will overload the assignment operators, we will need to follow how it was designed initially again. So when we do plus equal to, make sure we're adding something together. Okay. And when we have plus equal to as assignment operator, make sure you allow cascaded function call because all of that is by design. All right. So let's again look at 2 different ways to do that. Plus equal to member function. Here, I am using plus equal to again for my student class. So here, down here is my definition of plus equal to. And when I say plus equal to 5, I want that to add 5 to every single test group. So I'm going to add 5 to test 1, add 5 to test 2, add 5 to test 3. So you can think of that I want to use the plus equal to maybe as extra credit. And when I add numbers of extra credit to the student, I want that to be appended to all scores. Okay. Now, member function overloading. Member function overloading is when you have the function operator plus equal to as a function of the class student. So this is the class student, and this function operator whether plus equal to belongs to this class. Okay, so member function overloading. And here is my definition. I want that to be added to every single test. Yeah. Non-member function overloading. Here, I'm again overloading the plus equal to down here with regular function. And this function does not belong to class student, right? It's just a regular function called operator plus equal to, takes in left-hand side, right-hand side, run our logic here, return student reference or cascaded function call. That's all. But for us to do that, remember the s dot test1. Test1 is private. For this regular function to run s dot test1, s dot test2, s dot test3, it needs to be friend. So on the left here, I also need to add friendship. I need to do friend space the signature of this function that match. So that this regular function will now have access to test1, test2, and test3. Yeah? Yes, question.
Wait, so for line 6, what are we like passing? Are we passing the S or the student end symbol?
The S and the I. So left-hand side and right-hand side. So look at line 18. The left-hand side is student. The right-hand side is integer, right? So that's the left operand and right operand. So that needs to match. So the first parameter is student S and int I. Yeah?
So wait, so line 16 and 17 we're basically creating an object.
Yeah, the 16 and 17 we're creating two objects. Yeah.
And what's the values on the right side, like the May 89, 90, 75?
Oh, those are constructor. Remember constructor where we just create an object and we have initial value for the name, test1, test2, and test3. It's a constructor for the class S0. So at the end of line 16, you will have an object S0 with name equal to May, test1 equal to 89, test2 equal to 90, and test3 equal to 75. That's just initial value for those.
Wait, so from my understanding, like if it's like private information, if it's like a bank and like your
it's private,
like how much you have, and but the information is private, so we use constructor to set values to private variables.
For constructor, yes. Constructor can set initial value to private variables, yes. But it can only once though, right? Because it's constructor. It's construct time. When it's created, you can do it. After that, you can only use mutators, right? Setters or getters together.
Okay, and without that, we cannot get access to the private variable.
Exactly. Right.
Okay.
Unless it's friend, right? That's why we need friendship at line 14. Is that 7, 8, and 9 will not work if I'm not friend, because like you said, they're all private. You cannot change them. You cannot access them. You cannot read them. Okay. But I want to because my plus equal to operator wants to add 2 to every single one of them. So for me to be able to do that, I have to declare friendship at line 14.
Okay.
Right. Okay. So now look at the summary of the member function versus non-member function. So this is the same screenshot from the previous slide, just the main function. Object S0 plus equal to 2 should add 2 to all the test scores of May. Two ways that we did it. Member function overloading, where we have a function called operator plus equal to belongs to class student, takes in the right-hand side only, which is the integer I. And then inside the function, the this pointer then become my left-hand side student. So I have student as test1 plus 2, test2 plus 2, test3 plus 2. Return star this for cascaded function call because it's assignment operator. On the other side, on the bottom side is the non-member function overloading, where this function is a regular function. It does not belong to class student. If the function name is operator greater plus equal to, that takes in both the left-hand side and the right-hand side. The left-hand side is student S, right-hand side is integer I. Then in the function, I can do S dot test1 plus equal to 2, S dot test2 plus equal to 2, and S dot test3 plus equals to 2. Return the object S as a reference so that we can do cascaded. Right? So for things like this, you could choose. You have the option of choosing member function or non-member function. Depends on your preference. This is again where the software engineer style will come in. So try both, figure out your style, which one you like better, and stick with it, and you'll start to develop your coding style. All right. Another operators that we have been using quite a lot for CIN and COUT are insertion and extraction operators. Remember the greater than and the smaller than? Those are operators. This one is used for CIN, right? So where you extract from CIN into variable, so extraction operator. And this is using for COUT, where it's insertion operator. You're inserting the value to COUT so you can print. Both the extraction and insertion are binary operators because you always run it like this. You do COUT, insert I, right? Or CN, CN, extract I, right? So you always have left-hand side and right-hand side. However, this is a little bit different than the previous operator will do it. The previous operator, the left-hand side and the right-hand side, the left-hand side is always our object. For example, if we go back here, S0 plus equal to 2, student class is on the left. If we go back further, S0 greater than S1, S0 greater than equal to S1, students are all on the left-hand side because that is our class, student. So when we're overloading, we overload for student and that match because that's on the left-hand side. But for the insertion and extraction, our class is on the right-hand side. Okay, so that's not the same as any other operators where our class is always on the left-hand side. For CIN and COUT, for insertion and extraction, our class are always on the right-hand side. When you encounter an operator where your class, right, a student or integer or any other things, happens to be on the other side of your operator. So meaning that your operation doesn't start with your class, it starts with COUT. Your class comes later. You can only use non-member function overload. Okay, so this is corner case, this is special case. Again, when you have an operator that your class, student or account, any other class that you define is not on the left, it only have it's on the right, you can only use non-member function overloading. Okay. So why is that? Remember what our member function overloading looks like? Member function overloading will take the left-hand side as the class operator, right-hand side. However, when the left-hand side is not our class, you cannot do this anymore. Right? Again, look at here. When we do member function overloading, the class is the left-hand side, the parameter is the right-hand side. But for cout, it's not our class. So you cannot do member function overloading. But you can still do non-member function overloading here. So that's why we cannot use that. So here I say, if we want to use member function overloading like before, what you will have is I on the left-hand side extraction to cout, which is not how we run the cout. Cout always go at front and then our class. Right? Therefore, this is not valid. You can only use regular function, non-member function. Okay. And the way that you use non-member function overloading is similar. You have the operator and then the symbol with left-hand side as the first parameter and then right-hand side as the first parameter, and that's it. So that will work. All right, let's look at our examples of this. Insertion and extraction. Both of those cannot use member function, so they will both be non-member function. Okay. Here are example of non-member function overloading. Make sure that cout, which is the insertion operator, will take in O string. Cout is O string, right? So O string, again, pass by reference, that's going to be our cout. And then your object, student. In here, you can write your cout regularly. Right? So here output is going to be my cout. I just do cout for output, test 1, test 2, test 3, my test 4, and my, you can do however you want. You can insert as many output you want. At the very end, make sure you return this output because the output is going to go back into cout, and then you can print it out. So you see, for cout, we return O string for cout by reference. Okay, so non-member function overloading. Function name, first parameter, second parameter, return type. You can do whatever you want here for cout. You can just input that. You can do, you can do new line, you can do space, you can do format even, right? Make sure at the end you return output that match O string. Similarly to cn. Cn is I string. Okay. Extraction operator I string is going to be cn as our input and your object, which is student. Now you see that here I have constant student because I'm printing that out, I'm not modifying it. Versus here, I do not have constant reference because cn, you're going to assign value to it. So here you have input 1.test1, 1.test2, 1.test3. And here you can also have some logic if you want. So here I actually calculate the average right after I pick the mid. Then make sure again you return the input as I string by reference. Your insertion and extraction operator overloading will always look like this. You will always have those. The only thing you will change is within the function. You will even keep the return type, right? So here, the only thing you will change are going to be those 2 lines. The only thing you don't change will be those 4 lines. Because you will always return output, you will always return input. Okay? Now again, make sure you have friendship declared in your class. So friend, OS stream, operator less than, insertion, and then OS stream reference, const student represent. So that match this, the signature. Make sure you have the exact same signature up there so that you can match. So signature, friend, again, signature for extraction, and then friend. Make sure they match. So that is operator overloading for insertion and extraction. Yeah, question.
Wait, so the two pictures, are they in two different files?
Yeah, so this is class student, right? For this one, yeah, this maybe you can put this in header file or you can put it in the same file. It's up to you. For the next project assignment, I'm gonna start asking you to split them. You'll need header file, you need source file, you need main, right? But when you are running this, that can be the same file.
Okay, and wait, I'm not sure what I forgot what the friend function is for.
So the friend function is allowing a regular function, like here, like two functions, to access all the private.
Oh, okay, okay.
Yeah, so access all the private.
And it passes a parameter of OS stream.
Yeah,
So
it's for CL. Yep. And IS stream for CN.
okay. I'm almost getting it. Not there yet.
No problem. Yeah. This is a little bit more complicated, but the good thing about insertion extraction is that you don't have another option. You always do it like this, exactly like this. You don't have, say, like previously, you can choose to do member function, you can choose to do non-member function. You don't have a choice here. You can only do it this way. This is the only way you can overload insertion and extraction operator. So no matter what class you do, all of those will be the same. You will have a different class here, and you will have different logic inside. Depends on the requirement. You will always have the same return type as well, because you don't have any other option for insert and extraction. So take some time when you write it, right? So right now I take a screenshot and I'm just reading it for you. It's going to be a little bit more difficult. But when you actually program it, it will make more sense, right? Because you'll be like, okay, this is return type, function name, first parameter, second parameter, implement your logic, return, right? So that will help. Right? Okay, so let's see how we can use it. I'm gonna have a student P and I will see out, please enter the score, separating by the limiter. Remember before, we will have to cn p dot test 1, p dot test 2, p dot test 3, and so on. Now, because I have overloaded the operator for student, okay, I don't need to do that anymore. I can simply do cn student pupil. When I run line 37, what the compiler will do is to look for function operator greater than operator extraction. That takes in a parameter of iStream and a parameter of student, which then will lead the compiler to our operator overloading up here. And if we go back here, that line of taking one student as one, student of test 1, student of test 2, student of test 3 are all included in here. So in the main function, you don't need to write all those out anymore. You can simply do cn pupil, that's it. Okay. Similarly to cout. Cout will run regularly for any other object except for student. Whenever we have cout, insertion operator, student object, we'll instantly go look for the version of student we implemented. The function name is called operator less than. First parameter is old string, second parameter is student. So that match this. Then it will go back to the definition of that. And here's my format of the output. Test1 s space the score new line, test2 s space the score new line, and so on. Even print out the average. So as long as I have line 39, that will produce all those in the output. Because I have implemented as a function and I have overloaded this operator. Okay. Yeah, question.
Wait, so for line 37, what value are we inserting for
While we're
pupil?
inserting? Yeah, so we're inserting that. You see the definition here? I have input, test1, test2, test3, finish. I have some other logic to calculate the average, but that won't impact my input. So what you're taking is test1, test2, and test3. Right?
Wait.
Yeah.
Wait, so what's the value of input then?
I'm sorry, what was it?
Are we inserting or extracting for that line? The input greater than 1 dot plus 1?
I see. So remember Cn? We are taking Cn. Remember this is like week 3, this is probably too long ago. But when we talked about Cn, we said Cn itself is kind of this storage where we draw a table, remember, where each of the cell has a letter in there that's taking in, and then we parse it one by one. Those are all in Cn. So even though we're inputting, it's using the extraction operator because you're extracting the number from a file, for example, store it into variable test1, extracting that, store it into operator test2, and then storing into operator test3. So that's why you're saying like, oh, but we're inputting. But yeah, we are using extraction operator to extract from your input. Either it's a file or a terminal, store it into the variables. So that's why it goes this way, right? That's why it's pointing that way. So it's taking from here, storing here, and storing there. So that's the scene. Yeah. Any other questions? Okay. So extraction and insertion operators are special case, right? All the other operators, you can choose member function, non-member function. Okay. Finally, we have unary operators. Now, this is where the operator only takes in one object. Before, we always been dealing with two, right? Two students, or student and an integer, Cn and a student, or Cout and a student. Here, we are taking with operators that only handle one operator. Okay. Here, we are taking with operators that only handle one operator. Okay. You still have a choice. You can do member function or non-member function. Now, here's a very short example of the member function, non-member function. So here we're looking at this operator not, right? Exclamation point. So that is not operator. Now whether you have used a regular not. So if you have this in front of a true statement, it will return into false. If you have that in front of a false statement, that will return into true. Okay, so not whatever condition. Now, when I have not student, so what I will use it for, let's go here, is that I want to make sure that my student is not null or not empty. So when I have a not operator, right, it will return a Boolean, true or false, right, whether your student is none or whether your student is null. And all I want to check is whether there's a name. If a student does not have a name, then yeah, this is not a student. If the student does have a name, then yeah, it is a student. So that's what I want to use to identify the not. So this is again, will return a Boolean, true or false, right? Whether this is a student. It will take in a parameter student s, yeah. And because it's a comparison, I can make it constant. Now all I'm returning is whether the name of student s is empty. If it is empty, then it will return true, saying that this is not a student. If it's not empty, it will return false, saying that it is a student. Okay. So on the left-hand side, non-member function. On the right-hand side, member function. Non-member function is a regular function call, return Boolean. Function name is like this, takes in one object. Make sure you have friend so that we can do s.name because it's private. So make sure you have friend. On the other side, it's member function overloading. This function itself, over here, this function itself will become a function of the class. It will return a Boolean and it will take in no parameter, right? Because there's only one operand. So there's no what we call right-hand side. So here the definition is the same. Instead of s dot, I will use this pointer and also compare whether the name is null. If the name is empty, this is not a student. If it's not empty, then this is a student. Question?
Wait, so for the left picture, so line 6 and 17, why did we create the same function operator?
Oh no, line 6 is friend declaration. This is just friend.
Wait, so what's line 17 then?
17 is the function definition.
Okay, so
yeah.
Line 6 is telling the compiler that operator, I'm not sure what symbol is that.
This explanation. This is the not. So we call it not.
It's so line 6 declares that operator not can take the values, the private values.
Exactly.
And line 17 is also gonna declare the same thing and add all the body of code.
Yeah, exactly.
Okay.
It's at the body of code. Yeah, the logic behind. Yeah.
For the wait, I'm just not sure what the difference. I was googling it a while ago, the non-member and member functions. I'm not sure what, because they look the same to me on the.
So on the right, you see that line 7?
Yeah.
Line 7 is, line 9, 9. 9 is saying that this is a function that belongs to class student.
Okay.
Right, so that's member function. Line 6 is not defining anything. Okay. Line 6 is saying that there is a function that is a friend of class student. So line 6 and line 9 are different.
Oh, since it's like outside, it's not like inside the public.
Yep.
I was like confused because it's inside the.
It's inside the class, right?
The bracket.
Yeah, inside the class.
So
yeah, that's a little confusing because when you declare friendship, you have to put it inside the class.
Okay.
Yeah, but this is just friendship. This is just friend. The function is down there. It's down at 17. Yeah.
Okay.
Versus here, the function is inside 9. It's line 9. It's inside the class. So also, if you look at the definition here, you see line 17, I have student scope, operator not. Versus line 17, I don't have student scope. It's just operator not. It's just the function. So line 17 is telling you that, oh, this function belongs to student. That's why I have the student column here. So that's also another difference.
Okay.
Yeah, so that's the member function, non-member. So I see a question. Whether can I define the operators? No, you cannot. So remember, we have a very strict naming convention for operator overloading. It has to be operator with the symbol. So you cannot like write. If you say operator underscore not, that's just a regular function name. It's not operator overloading anymore. So you have to do operator and then the explanation. Yeah. Mm-hmm. All right. Let me check on time. I think this is the last one. Yeah, exactly. All right, let's finish this. Pre and post increment. Now, some of you already asked me, right? Oh, what's the plus, the increment by one thing? Yes, that is unary operator, and that is the increment. So there's a pre-increment and there's a post-increment. Remember, the pre-increment is where you will increase the object, then return the incremented value. And the post increment is where you increase the object, but you do not return the incremented object. You return the old one. Remember that? That was from in class last week. Right? So the pre-increment and the post increment. Now, when we are overloading the pre-increment and post-increment, they are exactly the same symbol, right? They're plus plus. The only difference is whether it goes at front or whether it goes after. But when we are overloading, we don't really tell the compiler whether my operand is at front or whether my operand is after, go behind, right? So there needs to be a way that the compiler distinguish between pre and post increment. And the compiler is doing that by adding a dummy parameter. So this is again another corner case, okay? Where here we have pre-increment, where it's an increment with no parameter, versus post-increment is down here, whether it's operator increment with an integer. This integer does not mean anything. It's a dummy integer. It's not actually taking an integer value. It's there to distinguish the pre-increment and the post-increment. That's all. Okay. All right, so let's look at this in action.
I have a question on the last one.
Yeah.
So for line 9, we're passing by reference. Since there's
right.
N, the N symbol.
Yeah.
The
okay.
N.
Yeah. Remember what the pre-increment returned? The pre-increment will return the incremented version. So it will return itself. Remember, okay. Whenever it returns itself, you will always do reference. Right? The return type will always be student reference.
Okay.
But the post increment, it will return not itself. It will return the non-incremented version. So that's what the post increment means, that you increase it, but you don't return it. So that is the post increment. Yeah, so that's why it's just regular student, because you are going to create a copy. You will see where you're going to create a copy and you return that copy. So that is the post increment.
Okay, so like C++ is like the post increment of C, like that.
No, so that's a very I haven't thought of that. No, so the plus for the regular or the default plus is only used for numerical increment, right? Like I plus. Remember you asked about the for loop, the I plus, J plus. Now we want to also do something similar here. Only increase one. So the plus will always only increase by one. When we overload it, we also want to increase by one, but somehow increase one in our object. So for this will be increase the student test scores. But yeah, that's a keen observation of C++. C++ would probably be the post increment of C or something. Yeah. All right, so let's see how we implement it. Again, plus only increase by one, right? However, in my class, I have 3 test scores. I have test 1, test 2, and test 3. So I want to increase all of them by 1. Here's my definition over here. Again, this is just how I implement it. It's, you can do however you want. For my student, I have operator plus plus, so that is pre-increment. This is a member function, right? So example of member function. I also have post increment, so operator plus plus int. So this is in post increment. The difference between the two is that the return of the this point. Pre-increment will increase and return yourself. So increase the this test 1 plus plus, this test 2 plus, this test 3 plus plus, return this. So this is for cascaded function call, right? Return star this, return type student reference. So you've seen that quite a lot already. So that is the return yourself. Post increment is a little bit tricky because you increase it, but you do not return. You want to return the old version of yourself. The way we do that is we first create a copy. So you see here, line 30, I will create a temporary student called temp. That's a copy of the this pointer before I increase, right? So I first create a copy, and then I start to increase test 1, test 2, test 3 at the this. And finally, I do not return this. I return the old copy. So that's post increment. Let's see how it looks here. So here's my main. I'm gonna run 3 version. So again, student S1, student S0, student S1. I'll first run pre-increment, then I'll run post-increment, and finally I'll return S1 to see whether it was actually increment. So here again, our chart table to show exactly what's happening in memory. So we started with May, 89, 90, 75. Then 75, 86, 92, right? So that's my S0 and that's my S1. All right, let's start running line 58. Line 58 is pre-increment. Pre-increment will jump to this one, right? So that's pre, that is post. So pre-increment. Let's run pre-increment. So we'll first go to the line 19 over here. And the minute we get there, the this pointer right now is pointing to the object that's triggering the increment. So S0. So that's my this pointer, right? Remember the this pointer from class 3? So now that this pointer is pointing to S1, S0, so we're operating on May. Let's run 21. 21 will increase test 1. So that will turn to 90. Line 22, increase test 2. So that will become 91. Now, test 3, increase 75, so that will become 76. Then finally, we're going to return this pointer. So what is this pointer again? That's S0, right? So return S0 back to my line 58 and then print out. So when I print out, I should have this line. Test 1 is 90, test 2 is 91, test 3 is 76, right? So the incremented version. Before we had 89, 90, 75. When I print at line 58, it will be 90, 91, 76. Each test score got incremented by 1. Yeah, so that's the standard pre-increment. All right, now let's go to 59. Yeah, question?
Wait, so with the post increment, like when we declare the student temp equals to this pointer, like since the pointer, shouldn't it be pointing to the same data?
It would. So yeah, I will show that very soon in the memory. So yeah, so let's get here. Yep. So post increment, line 59, right? Line 59, we're doing post increment on S1. Okay, so it's this one. And that will give us to line 28 here. And you're right. The this pointer right now is pointing to S1 because we are at line 59, and this pointer is whatever is triggering the post increment. So S1. So that's like this point. What is happening here at line 30 is that I'm creating a copy of the current version of this pointer, which is this S1. And what is S1? That is Zen 95, 86, 92. That's line 30. Yes.
But isn't it a copy of just the pointer? So like the actual data?
No, so it stored this. So dereferencing this. Yeah.
Oh, okay.
Yeah, the star. Yeah. Okay, I see. That's what you're asking. Yeah, the star is dereference. So it's taking the content of this pointer and copying it over to the student. Yeah.
Hey, Professor.
Yeah.
Yeah. The in the 9:30. The stars as a star means the reference, right? Does this mean here mean address, right? But this is just a pointer, right? What
yeah, this is a pointer. So this is
pointer.
Not yes, that's different. Yep. So the pointer of star, that's dereferencing. Dereferencing meaning that whatever you're pointing to, give me that.
Okay.
So that's why it's S1. Yeah.
Okay.
Dereferencing. That's different than accessing the memory. The memory itself is an address. Dereferencing is reading the address and give me that address value. And whatever the address is S1 right now. So that's why it takes S1. So that's dereferencing. All right, so yeah, so we created a copy of the content of the disk pointer, which is S1. So that's what it got created down here in Zen 95, 86, 92 because of this line. And then when we run 31, 32, and 33, it's operating on the disk pointer, meaning that I am going to change up here. The disk pointer is S1, right? So when I do 31, this is going to be 96. And then when I run the next line, this will return 87. And then finally, this will become 93. But at the end, I'm returning tap. So I'm returning the bottom one. Okay? Therefore, when we go back to line 59, the C out will print out tap. So print out 95, 86, and 92. That's post increment, right? Post increment meaning that I increase it, but I do not return it. I increase it, I return the old version. That's how the post increment got to that behavior, is that it will create a copy first, it will increase itself, but it will return a copy. So you can get this old version. Now, when I run line 60, meaning that I'm gonna print out S1. S1, however, is the incremented version though. So when I run line 60, when I print out S1, it will actually be 96, 87, and 93, because that's the new S1. Okay? Any question on this? Again, the pre and post increment will, again, you do not have a lot of options, right? You will always have this student reference as the return type, return starters for cascaded function call. And for the post increment, you always have a dummy int, and you always want to create a copy at the beginning and return that copy so that you can have the pre and post increment behavior in your code. Now I see Intai asks when we're going to use operator overloading, right? Operator overloading is when you want to use an operator for your own class. So all the example that I'm doing, I'm running different kind of operator for a class student, right? So if you don't have all the operator overloaded, you basically will need to move all the source code, like those 3 lines, that 5 lines, to either a main inside here. So in main, you won't be able to run 58, 59, 60. You will need to run those 3 lines in place of that, and then you run that in place of that, and then you run the temp again in here. So you can think of it's giving our user of the class student a lot more flexibility into using it. You don't have to write test1++, test2++, test3++. You can simply write student++, and it's all handled for you. So that's why at the very beginning, I show you the string, because you have been using string a lot, and you have been having the benefit of using the plus for string, equal for string, comparison for string. And the reason you can use all those nice operators is because the library string have already overloaded for you. Yes, so for Joseph, your question, the reason that we have the dummy integer is so that the compiler can distinguish between the pre and post. And in here, when we have line 58 and 59, the way that the compiler distinguishes whether I should call a pre-increment or whether I should call post-increment is by looking at whether the plus go at front or the plus go behind. Yeah. Any other question?
Professor, I feel if C++ didn't allow people to overload operator, then people have to write command like add.
Exactly.
Or
all kind of functions.
Print out or input like this. Yeah.
Yep.
But C++ is very possible. It allows people to overload its operator, because in Java you can't overload operator, because Java C consider operator is very fundamental.
Yep.
Yeah, you can't change it. You need to write your own version of add or print out or
exactly
or like these things. Okay.
Yes. Yeah. Yep, that's the difference, right? So C++ gives you a lot of freedom, right? That's why we call it low level. Low level as in you can do whatever you want. We give you a lot of freedom, and it's fast, and then you can actually program using it for system, for server, or for a new kind of programming language because of the freedom that it gives you. Like you said, right? For Java, you can, if you want to write something like this, you have to have a function called add, or you have to have a function called pre-increment that you spelled out, right? You have to have a specific function because that is designed for user, right? You are using it as a programmer, but you are not programming something for other people to use. So that's where the leveling comes from, right? Python, right? You can't do anything like this in Python because it's even more higher level and it's more user friendly, but it's not necessarily programmer friendly. You can use it to do a lot of things. Doesn't mean that you can use it to write things to serve other programmers. Where C++ gives you this flexibility. Yeah. Any other questions?
We have a question on line 21 to 24
Yeah, here.
about the pre-increment.
Yeah, pre-increment.
Wait, why is the plus signs after the isn't pre-increment supposed to be before the
Yeah, this is a very good question. You can totally do that as well. So the reason that I put post here, because for this specific function, it doesn't matter because I am not returning it. I don't care when it's returned. So you see the pre and post increment, the only difference is the return type, right? It's what it's returned. Here, when I'm doing test 1++, test 2++, test 3++, at the end, what I'm returning is this. So it doesn't really matter whether that I do pre or post. You can for sure do pre, yes. You can even write out this test 1 equal to test 1+1. So you can write, yeah, you can do however you want. So you can choose to use pre or post when you don't care about the return type, which is over here. I don't really care about the return type because I'm gonna return this anyway. So yeah, so you can choose how you do this.
Okay.
Yeah, so that's why.
Will this be included for the project 3?
Yes, yes. So that's why I have provided example, detailed example for insertion, extraction, and also pre and post. Because you have all the example here, then you can refer back to here for your project 3. And to be honest, for both the pre and post increment versus the instruction and extraction, it's gonna be like very much the same. When you write it, it's just gonna be, you come back here, you're just gonna be writing the same function with different class, that's all. Because you don't have many options. They're both corner cases. For other regular operator, you can choose. You can either choose use member function, non-member function. But for the pre-post, for the extraction and insertion, you don't have a lot of options. So that's why I provide like so much detailed example of those for you to use as a reference for your project assignment.
Wait, so I usually do the slides and I type the code out, but how do I know which one belongs to the header file, the source file, or the main?
So anything in the class will be in the header file. So I crop a little bit at line 4, but 4 to 16 will be in the header file, right? Anything else will be in the source file. Just say, let's go back. Anything up here, right? Anything belongs to the class goes to the header. Anything else goes to the source.
Wait, and the
Header, source.
line 17 belongs to the source file?
Yep, because that's out of the class declaration. So class ends at 15. Right? The class ends at 15 here, over here, class ends at 15. Yep.
Wait, so you're saying that we can put the code in the class file and the in the header file together since they're on the same?
Oh, you cannot. No. So you mean for project 3, right? Or do you mean like?
Yeah, I'm just wondering why we didn't put the bool student operator not in another file. Why is it on the same file as well?
You can. So for project 2 extra credit, I said don't need to split them because you can put them like here. This will work. You can put them in one single file. Now project 3, I want you to try to split it. just practice basically, right? But when you write your program, you have you can choose when you after this class when you're writing a software, there's an option you can either put them together if you want, or you can split them. Split them, it's a preference, right? Most people like to split them, especially when you have a very big software. If you put everything into a single file, that file will be 1,000 lines long. So that's why people tend to split them. So for project 2, extra credit, I ask you not to split them so that you can see that, oh, I don't have to split them. For project 3, I'm going to ask you to practice splitting them. That's all. Both work. Both work. Yep. All right. Any other question?
Oh, that's all. I'm not sure what questions to ask since it's
Yeah, that's all. So that's basically the end of the day. Yeah. So we did the main concept is the operator overloading. We gave a lot of examples on the how to overload binary and unary, and we went into detail of insertion, extraction, and pre and post because those are kind of the corner cases, and you don't have a lot of choices for you to overload them. Here's a summary of the rules. Overloading is not automatic. You can use non-static member or non-member, right? So we show 3 examples of both ways. You cannot create new ones, right? We talked about this. And then you need to follow the existing operator. Sorry about that. You need to follow the existing operator definition, including return type definition behavior. Yeah, that's all for today for the operator overloading.